The basic agenda for today is we're going to cover four essential topics to sketching. So there's the dimensions, expressions, and relations, creating splines and curves, and then we're going to talk about projection and intersection curves, where you can bring that external geometry into the sketch. And we're also going to mention pattern and mirror operations. So this CES isn't necessarily for someone who's never ever touched NX sketching before, but maybe someone who's played around with it a little bit and just wants to gain a little bit more knowledge. So we're going to finish off with a demo as well, and in that we're gonna cover all that we talked about before in a little bit more depth and showing you exactly how you can use that. So we're going to start off with dimensions. So there's really two ways to dimension a sketch. So you can bring up the rapid dimension tool with D, or you can alternatively click on or select two points or a curve, and it'll bring up directional dimensioning options, which I'll show as well in the demo. You can see there the box, it starts out without any dimensions. If you select one of the edges, it brings up that length, and you can click and drag to adjust it or type a specific value. And then once you've done that, it'll turn solid black to show you that it's confirmed. So we also have expressions, and this is how you sort of relate dimensions to one another. So you can name them and formalize them. If anyone's worked with something like MATLAB or just simple I guess mathematical formulations. You can, for example, in this we have that the outer circular diameter is exactly half of the inner diameter, and you can do dividing, adding, multiplying, all those sorts of things to get constant relationships between two different dimensions. And last here in this section we have relations. So these sort of create directional connections between different curves. So, for example, if in this case you want to, at least I prefer to have the create persistent relations and display persistent relations turned on. So what the create persistent relations allows you to do is it allows you to use the make command to create relations which can constrain and define the sketch. Because by default, they won't be able to constrain the sketch. They'll just allow you to move those curves where you want them, but it won't hold them in place. And the display persistent relations is just something nice to have on because it lets you keep track visually of exactly what you have related to one another. For example, in the figure there on the right, you can see we have circled we have the vertical and the tangent as well. And you have the make bar up here, and I'm gonna walk you through those as well during the demo. But one thing to remember to note is that NX will automatically relax those relations when you edit a dimension. So there's sort of a hierarchy at play, and relations are below dimensions. So if NX is forced to choose, it's going to break one of your relations before one of your dimensions. Let's move on and talk a little bit about these splines. So splines are a great way to create smooth curves. And something interesting and important is that the more curves you have, or the more points you have, the more control you have of your spline. So there's a trade-off to that. The more points you have, the more complex and in-depth it's going to be to fully constrain that. But you can see that if with just using 4 points, it wants to create almost an egg shape. But if you add more points in between there, you can see we get closer to that perfect box shape. So more points, more control, but a little bit more complexity. And you have some additional options with these splines. You have the option to close the spline, and that's just going to create a smooth polygon. So just closing the loop. And you can create extensions at either end of it. And an important thing about that is it doesn't extend in a perfectly straight line. It extends following the curvature of the preceding section. You can define these with either points or poles, but note that you need at least 4 of either before to let you define it. And we also have these projection and intersection curves. So these, if you have some sort of external geometry, you can select edges or faces respectively and bring those into your sketch. So for example, the project curve tool, you can project curves, edges, and points from outside the sketch onto the plane. Whereas the intersection curve will take the intersection between that geometry and your sketch plane and create curves there. So it's all down to what you prefer. Recently, they've also added the include tool, which is a bit newer, and it's very similar to the project curve, but instead of solid curves, it projects them as reference curves. And it allows you to also select points along extruded curves, whereas the project curve doesn't. You can select points from external sketches, but when it comes to the extrudes, it just allows you to select the curves themselves rather than the points. The pattern and mirror operations are very nice because they save a lot of time. And so they really allow you to create these finer patterns that otherwise you will have to do manually. But that's something luckily we don't have to do. And there's 3 ways to define the spacing of each member. And so that's count, pitch, and span. And when you define your pattern, you have to choose to use any 2 of them. So I often like to use count and span because oftentimes what I think about importantly in a pattern is how many members are in the pattern and the total distance. But if you wanted to, let's say you have your total distance and what's really important to you is the distance between each member, you also have that option. That would be pitch and span. And so you can really define it, whatever's most important to you or whatever matches with your design intent. And the mirror tool, I don't want to say it's self-explanatory, but well, it mirrors the curves across a center line. And so the center line can be any straight line of your choosing. It can be the axes of the sketch or a straight curve that you've created within it. So that gives you a lot of options to, if you have the symmetry, really only sketch a quarter of what you need and just mirror the rest. And so with the pattern curves, when you have the create persistent relation on, you only have access to 3 pattern types, but your members will be fully constrained at the end, so you don't need to individually define them. However, if you turn off create persistent relation, you can then gain access to all of the layouts, and you have things like the polygon and the spiral, but your members are not going to be constrained. So you'll need to go back in and individually constrain each of them. But you also get additional options. So you can create a boundary curve where it will create the pattern, but will ignore any members outside of that boundary curve. This is useful if you have an edge that you can't cross, but you don't want to define it in the pattern as such. You want to say, let's say I need this many total members, but I don't need the ones outside of the boundary. You can do that. And then you also have concentric members, which allows you to create concentric rings of circular patterns. And I found that to be useful a few times as well. The mirror, similarly, you have that create persistent relation option. And so with this, is similarly, if you turn that off, the resultant curves, you can edit them. Whereas if create persistent relations on, they're locked in. So depending on your intent, if let's say you have one mirrored side is almost the same, but not exactly, you want to be able to edit a couple small things, make sure that's turned off. So now that we've gone over all that, let's just hop into the demo, and I can show you some of these things a bit more in depth. So I have this model here. So what we're first going to do is we're just going to hop into a sketch. And good practice is rather than to select these datum planes, create your sketch directly on the planes of the axis of the datum coordinate system. So I'll start just by creating a few circles. And you can see I have the option to basically stretch and compress them. And if I pause for a moment, it gives me a diameter option. So I'll just go in and set this to 20. Now this is locked in at 20, I can move it around, but if I pause again, I get the diameter option. And 12 for this one. And you can see if I align it, it'll pull up these relations for me. So let's just create a couple more circles. Let's say this one is 6, and this one is 5. So you can see they're brown, which means they're not constrained. So I can drag them along here, but it still wants to keep this relation. If you ever have something like that, just give it a shake, and it turns purple, and you can then move it wherever you like. So I'm going to make sure that my options are toggled on. So we turn on create persistent relations and display persistent relations. So we have options here for all of these relations that we can make. We have make coincident, collinear, horizontal, vertical, tangent, parallel, perpendicular, and equal. For today, we're mainly going to focus on these first few. So I'm going to use the make coincident to make the center of this circle coincident with the sketch origin. Select OK. You can see there's a subtle light blue there. That'll be more obvious in a few of these other constraints that I'll show you. Let's just go ahead and start dimensioning a few things. So like I said, you can press D. That's all I've done here. And it brings up the rapid dimension tool. So through that, you can select your first object and your second object, as well as the direction here. Horizontal is what we want. And so after you place it down, you have to exit out, double click, and you can set it to whatever you like. In this case, we'll say 30. And then we can have that set here. And so you can see this one is black. I probably should have pointed that out earlier, but that's it's fully defined. But what we can also do is rather than using the rapid dimension tool, if you just select two points here, NX will come up with these dimensions. So you have the point to point, the vertical, and we've already defined the horizontal, so it's not going to give us that one. But you can just click on one of these, and you see here we have the option to drag in either direction, and we can set it to, we can also type in whatever we'd like. You can see here also we have these following one another. Shake that off, and let's make this this circle coincident with the center of this circle. Say OK. And then I also want to define this circle to be vertical to this circle. And so now I have that locked in. So this one's still brown because we can move it up and down, just not left and right. See, I shook it a bit, that broke it. So we'll just put it back. We can do a Control Z. And then let's define the vertical distance here. Sometimes it's a bit hard to grab the points. Just select the outer edge and select the inner edge, or the inner point. It's a bit easier. Let's see, we lost it there. Pretty easy to get it back though. There we go. So we just click on it, type in whatever value we want, say 6. Now let's use some of these other relations. So I'm just going to put down a line. And often it's good to just place the line somewhere else and then work backwards, in a sense, sort of subtly refining and defining it closer to what you really want. So in this case, I want to make sure that it's tangent to both circles. So we use the make tangent. Our first curve is the motion curve. That's the curve that you want to move. And then the second one is the stationary curve, or the curve that you don't want to move. In this case, it wouldn't have made much of a difference since these are already fully defined. But that's just something important to keep in mind. So we're going to do it for this second circle as well. And it's going to move this line so that it's tangent to both. And you can see we have that light blue relation symbol showing up there. Also want to make sure that the ends of this line are coincident with these circles. So you can just hit apply and do the same thing on this end. Say OK. So we have our fully defined shape so far. Let's put in that spline that I talked about. So you can see here you can do by poles or through points. In this case, I'm going to go by poles. And you see we have a spline that follows those poles. And you can close it. Creates an interesting shape. If I were to, let's say, create the spline in more of this shape and press close, it would follow along a bit more. And then we can also, like I mentioned, create those start and end extensions. So here, let's say I want a 5-inch extension here. And if I make it a bit more obvious with, let's say, a 25-inch extension, you can see it's not straight. It does follow the overall curve. Let's go ahead and create the spline. We want to connect this curve to this one. Just going to go ahead and create that. So you can move it around. You can move the poles around. Kind of stretch it how you like. In this case, I want to create this pole to be vertical to this pole. That's going to define the horizontal movement of both with just one horizontal dimension. It's going to save a bit of time. So instead of using the rapid dimension, I'm going to do that method I showed you earlier, where you just select the pole and then select here. And so we have the vertical, the point to point here, and the horizontal. So for this horizontal, I want to make this a distance of 14 inches. Go back in and define our vertical distance as well. In this case, let's use 2 inches. And the distance between these poles, I want to make sure to define that as well. And so you can see, if you were to create a spline with many poles, 10 poles, 15 poles, you could be at this for a while, but depends on if you need that level of control. So it's that trade-off that we often see with sort of speed or simplicity and complexity, and like exactly what you want. But we can see here we still want this to be tangent. So let's hop in with this tangent constraint. You'll see sometimes the order in which you do these does matter. In this case, it worked out, but sometimes it gets a little fussy if you do things in the wrong order, if you start from a weird place. So never be afraid to sort of delete something and start over. And if that doesn't work, you can Control Z your way back to where you were. So it's all very, I guess, low stakes in a sense. You can always just don't be afraid to start over. And so what I'm thinking now is I want to make sure that these circles are related in size. So there's several ways to get to the expressions options. So you can right click on a dimension and you can select add or remove expression. You can also double click and use an equal sign and type that in, and it'll automatically come up. Let's say equal 6. So now I see it creates this expression. So it automatically names it P6. I'm just going to name it inner circle diameter at 6. And for the third way to get to expression, you can right click, bring up this, add annotation. Sorry about that. And you can check the expression box. So that's sort of the most manual way to go about that. But I'll name this outer circle diameter. And you can see that I want this to be equal to the inner circle diameter. And so you see I start typing, and it comes up with options for me to use. So I'm going to say inner circle diameter times 0.5. And I can see whatever I select this to be, this circle will be half of this larger one. So let's say I want this to be 8 or 4. They change together. And just by pressing E or Control E, I can get a list of all my expressions, and this makes it easy to have everything in one place, and you can edit these formulas as you wish as well. So I'm just going to put in one more circle, so sort of demo some of these patterns here. And so I'm going to use the rapid dimension tool this time. I'm going to add in a horizontal dimension and a vertical dimension. So if you double click on it, you can also just drag it. So I want 2.5 here as an example, and 2.5 here. There we go. And now let's work with these patterns. So just select the pattern tool. I'm going to say that I want a circular pattern in the case of this circle here. So you have your curve that you want to pattern. So you select whichever curve you want, and then a rotation point. So that's your center point. It's going to be the center of this larger circle. And so we can have count and pitch, count and span, and pitch and span. And those are those sort of definitions that I touched on earlier. So I'm going to go with count and span. I want this to span across 270 degrees, but you can either type in a different value, let's say 180. You can drag. So there's lots of different ways to do it. There's the it's intuitive, and you can also change the count to whatever you like. I'll say I want 7 here, and you can select OK. Now we also, in the pattern tool, we have the linear option in this case, since we have create persistent relation turned on. And so again, similarly, we select the curve we want to pattern, except this time instead of a rotation point, we have linear objects. So I'm going to use these axes of the sketch. So you can see we have one direction and we also have a second direction. So let's say we only have want to do one direction. We want 3 count and a pitch distance of 5 inches, so that's 5 inches between each member. So we can switch the direction as well, or we can use a second direction. So I'll select a different linear object in this case, and we can flip the direction and change the settings if we want. But this is exactly how I'd like it to be. So we can just select OK. Now I'm going to touch quickly on the project curve features. Here, this isn't going to have a big impact on our sketch, but it's important to show here. So this is an extrude that we've already made outside the sketch. And here in the More dropdown, we have project curve or intersection curve. So you can see project curve. If I just select these sort of edges, it'll project the curve into our sketch. So that takes these curves and projects them onto the plane. And we also have intersection curve. So here you'll see you don't select the edges, you select the faces. So if I select these 2 faces, we should expect to find a curve here. And if we select this face as well, it should intersect there, and we can see that it does. So I'll Control Z those away. I'll also show you the include option. So that works similarly to project curve, but you can see here I have the option to bring in these points. And they're dotted lines, which means they are reference curves. So these won't show up outside the sketch, and you won't be able to extrude them, but you can use them to reference to other curves if you want to dimension off of them. So I'll Control Z those away as well. And then one last thing I want to do is I want to trim these circles to create an open area inside here. And then you can see here we have these broke. So an easy way to check what's going on is just to click on it, move it around, and we can see here we've lost this coincident constraint. So we can just put that back in, select OK, See, we may have lost this other one as well. We did. So we just go in and put that back in. Select OK. Now it's back to black. So let's do the same over here. Really quickly, just put in these coincident constraints. And another option you can do, not usually my preferred method, but if you just select the 2 points, you see sometimes it's a bit difficult. You can just select the coincident. That's okay. And so it'll do the constraint as well. I just find it easier to bring up the window and work that way. And so we'll finish off with the mirror command. So you can drag across to select your curves, and we'll just select this as our center line. We've projected across here, and then I will just trim off this last bit here. So our sketch is fully defined. We have a nice even pattern here, circular pattern here. These circles are defined to one another. They are related through an expression. And so if we finish this off, we can then use the extrude tool to create our shape, our part. Thank you so much for coming with me on this NX Sketcher tips and tricks journey. Please, if you have any questions, we'd be happy to answer them.
All right. Thank you so much, John, for that wonderful presentation. So I do have a couple of questions. The first one is there a way to have NX warn the user an action will conflict with the user applied constraint or dimension instead of simply deleting it?
That's a great question. Chad, I know you're on the call with us. I don't want to give out false information. I think, but do you think you could confirm what happens there if that's an option?
Say the question one more time, Nika, because I was trying to listen in.
Is there a way to have NX warn the user an action will conflict with the user applied constraint or dimension instead of simply deleting it?
So the system will give you a warning if it's going to delete something. Okay, it doesn't just automatically delete. So it should give you the warning. But I know there has been some times myself where if I'm going and working on a part, I have deleted parts or deleted dimensions to put some others back in. So it should give you that warning.
Oh,
Yeah,
okay.
I do know sometimes it's not necessarily a large pop-up, but in the corner it'll say NX had to relax this to make this work. So it does usually tell you if I remember.
Yeah, in the bottom right-hand corner is usually where the pop-ups do appear. Because it's basically it's almost like a parent-child relationship. It needs one to create the other. Okay.
Thank you. Yeah, and we have two more. Where do you see the drafting preference at?
Drafting preferences?
John, you want to show her real quick where the
Yeah,
drafting preferences are located at?
yeah. Let me pull that up.
So one thing I do
Um,
want to note about the drafting preferences, a lot of those should be preset in your start models. So like, as you were seeing John give his presentation, I could see that he was an ISO standard. So a lot of times, we're on an ANSI standard in the US, ISO's over in, European, but as the software is created by Siemens, the default's ISO standards. So if you want to be setting your preferences, you want to make sure you set those up in your start models. But go ahead, John.
oh, I do know that in menu preferences, um, well,
Right there.
drafting would
Yep,
be
sketch right
yeah,
there. You're at
sketch.
the right.
Sorry, I heard drafting. I was in drafting mode.
Yeah.
Yeah.
So you can see there's the preferences here, and then there's also, this is a sketch preferences while you're in the sketcher, and then there's also drafting preferences that are available to you as well.
Great. And our last question, is there auto dimensioning with the new sketcher?
No, that was in the old Sketcher they had that, but as of now in the new Sketcher, there's no auto dimensioning as of yet. It might come in a future update, but right now, no.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.